Good morning, students. I hope you are all fine. So, today we are going to start our chapter circles. Before going through the exercises, let us discuss some important theorems which will be required in our order to solve the sums. Let us understand this first theorem. It says, now before discussing this theorem, let us understand what is a tangent. See, suppose this is a circle. Okay, suppose this is a circle. Clear? Now if I take any point and draw a line which just touches the point, okay, then this line, or rather line segment, will said is said to be a tangent to the circle. Okay, now our first theorem says that if there is any tangent to a circle, then the line through the radius, that means this, is always perpendicular to this circle, or rather tangent. So the line which passes through the radius is perpendicular to the tangent. That is what this theorem says. Okay, again let me repeat. If there is any tangent and there is a line which passes through the center, then this line will be perpendicular to the tangent. This is the first theorem. Proof is not important here, so we are just discussing the theorem. Therefore, next is, suppose this theorem 2. Okay, suppose we have drawn a circle and there is an external point. So now the question is, from this external point, how many tangents can you draw to this circle? How many tangents can you draw? The answer is 2. There will be one tangent, and there will be one tangent. Okay, these are two tangents. How many tangents can you draw? Two tangents. Okay, now this theorem says the lengths of these tangents will be equal. That means if this is an external point P and these are two tangents PA and PB, then this theorem says that PA will be equal to PB. Clear? This is our theorem 1. This is our theorem 2. Now this is our theorem 3. Theorem 3 says that suppose there are two concentric circles. You know what are concentric circles? Concentric circle means two or more than two circles which have a same center. So it says here's a concentric circle, and suppose there is a chord which is also the tangent of the smaller one. Okay, this line, suppose AB, this is a chord for this larger circle, and this is a tangent for this smaller circle. Now this theorem says that it will be bisected at this point. So AP will be equal to PB. This is our theorem 3, or rather you can regard it as example, but this is actually a theorem. Okay, so what does this say? It says if I draw a chord which is a chord for the bigger circle and a tangent for the smaller one, then this chord is bisected at this point of contact. Okay, point of contact is P. So the theorem says AP will be equal to PB. Clear? So these are our 3 theorems. Let us start the exercise then. Now, exercise 10.1 is quite, the short questions. So therefore, we are starting from exercise 10.2. Okay. Question number 1. Question number 1 says from a point O, from a point Q, the length of the tangents to the circle is 24 centimeter and the distance of Q from the center is 25 centimeter. The radius of the circle. They are asking the radius of the circle. This is the figure. This is the point Q. This is the point P. This is T. This is 110 degree. They are asking what is the radius of the circle. So it is given that PT is equals to TQ is equals to 24. Okay. And the distance of Q from the center is 25 centimeter. And the distance of Q from the center is 25 centimeter. What does it say? From a point Q, the length of the tangent to a circle is 24 centimeter, and the distance of Q from the center is 25 centimeter. Distance of Q from the center. Oh, actually, this is not the figure for question number 1. This is a figure for question number 2. So we need to draw our figure for question number 1. From a point Q, the length of the tangent to a circle is 24 centimeter. So let us draw this is actually figure for question number 2. So you need to draw the figure from a point Q. The length of the tangents to a circle is 24 centimeters. QA will be 24. And the distance of the center Q from the center is 25. So if this is O, then QO is 25. Okay. There was what is the radius? Here radius becomes OA. So OA is what? We know that this is 90 degree, right? So this is 90 degree, this is perpendicular, this is base. Clear? This is perpendicular, this is base. So OA square plus AQ square is equal to hypotenuse square, QO square. Don't know OA, so OA square. So 25 square Okay, 49. So OA becomes root 49. 7. Clear? Therefore, radius becomes 7 centimeter. Now question number 2. Question number 2 says POQ 100 then PTQ. This is very easy. There is the external point T. So external point T. This is P. This is Q. This becomes very easy. See, these are 90 degree. This is 110. So angle PTQ will be 360 minus. This is 110. So 110 minus. This is 90. This is 90. So 180. So 360 minus. Okay. Clear? 70 degree. Question number 3 is quite same, so we are not doing that. Question number 3. Let us do question number 4. Okay, let's do question number 4. Says prove that the tangents drawn at the ends of a diameter of a circle are parallel. Ends of a diameter. So suppose this is the diameter. These are the ends of a diameter. We have to prove that these are parallel. Okay. The proof is quite easy. Okay. This is O. Suppose this is P and this is Q. So let P and Q are the points of what you need to prove. We need to prove these two tangents are what? Parallel. So suppose here I'm giving name R and S. Okay, here are the points of contact. So this becomes point of contact for tangents RQ and SP. Clear? We know what OP is perpendicular to PS by theorem or first theorem. Any line passing through the center of the circle is perpendicular to the tangent. Also what you have, OQ perpendicular RQ. Clear? Therefore what you have, angle OPS plus angle OQR, right? So OPS becomes 90, OQR becomes 90. This becomes 180. Now sum of these angles becomes 180. That means what? They are allied angles. Therefore angle OPS and angle OQR are allied angles. Allied or cointerior, whatever you can say, allied angles. Now these angles can be allied angles only when RQ and PS are parallel, right? Hence RQ parallel PS proof. Clear? So the proof is quite easy. Question number 5 is just the theorem, so we are not doing it. Question number 6 is quite similar to question number 1. So we are skipping this one also. Now we are doing question number 8. Okay. So I'm erasing it therefore. A quadrilateral ABCD is drawn to circumscribe a circle. This prove that AB plus CD is equals to AD plus BC. So this is what they say. This is a circle, okay, and they have drawn okay. So this is our S, this is our P, this is our B, this is our Q, this is our C, this is our R, and this is our D. Okay, they have said that we have to prove what you need to prove. Prove that AB plus CD is equals to AD plus BC. Now you can easily say that these are tangents BQ BP, right? So the length of the tangent should be equal by our second theorem. What can we say? We can say AP is equals to AS, and we can say BP is equals to BQ. Clear? So we're adding these two, so this becomes AP plus PB is equals to AS plus BQ, right? Now AP plus PB becomes AB, so AB is equals to AS plus PQ. Clear? Also, what can we say? CR is equals to RQ. CR is equal to, sorry, CQ. CR is equal to CQ, tangents. Also DR is equals to DS. Now also I'm adding these two, so CR plus DR is equals to CQ plus, this is CQ, this is DS. DS, clear? Now CR plus DR becomes DC, right? So we have DC is equals to CQ plus PS. Putting at this one and this is at 2. Now AB plus CD, we're adding these two. So 1 plus 2 implies AB plus DC on the left hand side, and the right hand side what we have? AS plus PQ plus CQ plus PS. Now AS plus DS, this is DS, not PS. This is DS. I have to write the D more clearly so that you understood. Okay, it's DS. Clear? Now AS plus DS, I'm putting this together, AS plus DS. Now also I'm putting this together, PQ plus CQ. This is not PQ, this will be BQ. That's what I'm saying. PQ, BQ. Clear? This becomes BQ and PQ. As you can say, BQ plus QC, this becomes BC, and AS plus DS becomes AD, right? This becomes AD and this becomes BC. So we have whatever AB plus DC is equals to AD plus BC root. Okay, proof is very easy. Okay, let us do the next one then. Question number 9. XY and X dash Y dash are two parallel tangents to a circle. So the figure is being given. These are two parallel tangents. Okay. This is the figure. So XY and X dash Y dash are two parallel tangents to a circle with center O and another tangent AB with point of contact C intersecting XY at A and X dash Y dash at B. Prove that angle AOB 90 degree. What you need to prove? Angle AOB is equals to 90 degree. Clear? This is what we need to prove. Angle AOB 90 degree. Okay. Fine. So first of all, if I draw this, then OC is perpendicular to that. Okay. Now, as you can see, since XY and X dash Y dash are parallel, and we know the distance between two parallel lines are always same, therefore PQ is equals to AB. Or AB here oblique given. Here PQ is radius, but this is slightly oblique given. Okay. This angle is 90 degree. Okay. This angle OC is perpendicular to AB. So this is 90, this is 90. Anything am I missing? Angle AOB 90 degree. This is also 90. This is also 90. First of all, AP is equals to AC. These are 90-degree. First of all, see, AP is equals to AC, number one. OA is equals to OA, number two, common. Number three is angle OPA is equals to angle OCA, right? Therefore, triangle OPA congruent triangle OCA. Understood? OPA is equals to angle OCA. Both are 90-degree. Therefore, what can we say? Since they are congruent, angle POA is equals to angle COA. POA is equals to angle COA. Clear? POA is equals to A. Actually, these are equal. POA is equals to COA. Similarly, what can we say? Similarly, we can say angle QOB is equals to angle BOC. Okay, these two angles are equal. Now, if we can prove that triangle OAC and triangle OCB are congruent, then our proof will be suffice. So how can they be congruent? OAC and OCA. First of all, OC is common. And angle OCA is equals to angle OCB. So two part proven. AC cannot be equal to CB, right? But can they be congruent? Triangle OAP and triangle OQB. First of all, they are 90-degree. OP is equals to OQ. Both are radius. But third, am I missing something here? OPA is equals to OQB. POA is equals to POA is equals to COA. Those two are equal. Those two angles are equal. Those two angles are equal. Be congruent in this number one. into their tangent 90 degree. Third portion. Just a minute. It doesn't seem congruent, right? What more argument can I have? Yes, that can we can say PAO is equals to QAC, OAC. PAO is equals to OAC. These two are equal. Right? ICPCT. OP is equals to OC. These two are equal. QOB. QOB. Yes, these two are equal. How can these two be equal? So that AOB to 90 degree. What am I missing here? This is common. This is a 90 degree. Right angle hypotenuse. Are they equal? OA and OB. Distance between tangents. These, these are equal. This equal. Is this 90 degree? Hmm. This is 90 degree indeed. This is 90 degree. This parallel this. these angles are equal. OP is equals to OC. This is 90, this is 90. Sum of these angles are 90 degree. This angle plus this angle 90 degree. These two are equal, these two are equal. X, Y, Y. 2 into x plus y is equals to 180. So x plus y is equals to 90. That is how you prove. Now see. So what we have? POA is equals to COA. So if this is x, this is also x. Also, angle OAP is equals to angle OAC by similar argument, right? Is equals to, you can say, x. And then you can say y. Now since angle OPA is equals to angle OCA is equals to 90 degree, angle POA, POC plus angle CAP is equals to 90 degree. Clear? Since these two angles are 90 degrees, so their sum is 90 degree. Now POC means x plus x, so 2x, and CAP means these are equal, so y plus y, 90 degree. So what we have? 2x plus 2y is equals to 90 degree. Therefore we have x plus y is equals to 45 degree. Clear? Okay. Hence what we have? So all angles are equal. So angle POA, angle COA, angle BOQ, angle BOC is equals to 180 degree. Implies now their sum x plus y becomes 45, right? So this becomes 90 degree plus angle BOC plus angle COA is equals to 180 degree. Imply angle BOC plus angle COA is equals to 90 degree. Now BOC plus COA means what? Angle BOA. Angle AOB 90 degree. Clear? This proves our question. I'm erasing it therefore. Okay. Now let us do Question number 12. Okay, very important question. The figure has been given. In circle given. Let us draw the circle then. So angle ABC is drawn to a circumscribe a circle of radius 4. Triangle ABC is drawn to circumscribe a circle of radius 4 centimeters. This circle's radius is 4. So OD, O here D, here B, here C. This is 6, this is 8. So OD given 4 centimeters. Such that the segment BD and BC into BC such that the segments BD and BC into which BC is divided by the point of contact D are of length 8 and 6 centimeter respectively. Find the side AB and AC. So what they require? AB what? AC what? Now very easy. This is 8, this is 8, this is 6, that is 6. Clear? Now this point let us take P, and this point let us take Q. Now we have AQ is equals to AP. Okay, AQ is equals to AP. So if this is X, this is also X. So if I draw perpendicular, it will be perpendicular. Then area of right. Its area will be half into AP into OP. Its area will be AQ is equals to AP, right? Now area of triangle AOP will be half into AP into height OP. That means half into APX OP 4, because radius 4. So 2x. And area of triangle AQO will be half into AQ into OQ. OQ is also same. So no need for that. So I'm joining this. Okay. So they will be what? Equal or rather congruent. No, why? Because first of all, this is common. They are 90 degree. Number two. Number three, OA will be equal to OC. You know why? Because this is a in circle. In circle, the distance from center to the vertex will be equal. So they are congruent. So AOP area found. Similarly, area of triangle OCQ. Fine. OCQ is half into 6 into 4. Clear? Base 6, height 4. So 2 2s are 4, 2 6 are 12. Clear? Therefore, these since they are congruent, the area will be equal. Therefore, 2x is equals to 12. That means x is equals to 6. Clear? Therefore, AC, what we have taken x? X we have taken AP is equals to x, say. So AC is equals to then AQ plus QC. So AQ we have found x means 6, 6 plus 6, 12, and AB means AP plus PB, right? So AP is here 6 and PB is there 8, so 14 centimeter. Okay, so this proves this solves our problem. This is, students, we have completed this chapter number 10, this circle. Therefore, this chapter is complete. Thank you and have a very nice day. This is Srikant Roy signing out.